All right, so the last thing we talked about yesterday, we didn't get very far yesterday, but was transversal, or not transversals, but vertical lines, right? Or vertical angles, if I could learn how to talk. So if I had two lines that intersect each other, you got four different angles here. Remember this? So if I have 1, 2, 3, and 4, we talked about vertical angles. Which ones are vertical angles here? Which one? 1 and 2. Okay, I thought you said 4 and 2. Right, 1 and 2 are vertical angles. And what's true? What's always true about vertical angles? They're what? They're equal to each other. Exactly right. So 1 and 2 are equal to each other. So if I did this, I think this is the last thing we did yesterday, I believe. What if I said that this was 130 degrees, that angle right there? Could you find the other three angles? What's the easiest one to find? The one across from it, the bottom one right here. Okay, so what would this one be? Right, because they are vertical angles, correct? So if whatever that angle is, you just look across from it, and that would be a vertical angle, and they're equal to each other. What about the one right next to it, this one right here? How'd you get 50? Where'd you get that from? That's right. You went 180 minus 130, which is 50. So this would be 50. And now, you could do the same thing with this, or you could just look at it and say, well, this angle right here is what? A vertical angle with 50, so what's this one? That's also 50. So there you go. If I just gave you one angle, you should be able to find the other three. We good with that? Something you need to know how to do. All right. Now, what is the title of this lesson? It's Parallel Lines and Transversals. We discussed briefly what a transversal was. It's just a line that crosses at least two other lines, right? Intersects two other lines. But now what we're going to do, well, actually, we're not going to talk about parallel lines just yet. Let's do this. I'm going to go kind of quick. So write the stuff down that I'm writing. And let's make this one different color. There we go. All right, so I got two lines cut by a transversal. Now, are these two lines parallel? They're not, okay? They don't tell you they're parallel. I mean, just looking at them, this one's slanted quite a bit. This one's slanted just a little bit. Eventually, they will meet each other, correct? So they are not parallel to each other, all right? But we do have some angles. Let's put this in a different color. Let's say that this is angle 1, 2, 3, 4, 5. Oops. Still getting used to this tablet. 6. I changed one setting from the last class. It seems to be working a little better now. Okay. What I want to do is I want to look, and there's going to be some relationships. We know some things already. What angle is equal to angle 1 just by looking at it right now? What is it? 4. Why 4? Because they're vertical. Because they're vertical angles. That's the answer. Okay. If I say why are 1 and 4 equal to each other, what do you say? Because they are vertical angles. Vertical angles. What else are equal here? Give me some other angles that are equal. 2 and 3. Yep, they're equal to each other. Down here, 5 and 8, and 6 and 7. Good. You see them, don't you? All right. There's some other relationships. I'm going to use that word a lot. And I think students look at me when I say, what is the relationship between that? It's like how they're connected. What do they have in common, right? If you're related to somebody in your family, you've got something in common with them. Would you agree? Right? You got a parent, uncle, and grandparent. Okay, there's something in common. So that's what we're going to do here. So 1 and 4, they're vertical angles. That's what's in common. That's the relationship between them. Everybody hear me? There's some other relationships. Do you see how you've got a group of 4 angles up here and another group of 4 angles? Oops. Another group of 4 angles down here. Everybody see this? You guys watching, right? All right. Not everybody is. And they're talking while I'm trying to get you to listen. Do you see this group of 4 and this group of 4? What I want to do is, see angle 1 is up at the top left of that group of 4. Come down here. Which one's in the top left of that group of 4? Angle 5, okay? So we call those, they correspond to each other, right? They're basically in the same spot, all right? Angle 1's the top left, angle 5 is in the top left. They correspond to each other. So we give the name, it's supposed to be an O. I'll be saying this all day, but I got to get used to this tablet. Corresponding angles. Corresponding angles. Okay? So what I'm going to do is I'm going to list all the angles that are corresponding to each other. Which ones have we said so far? Angle 1 and what? Which one is corresponding to angle 1? Angle 5. Now notice, I did not put equals, did I? Just put a comma. I'm just listing the corresponding angles, okay? Which ones are corresponding to each other? 1 and 5. Why are they corresponding? Because they're basically in the same spot, right? 1 is in the top left, 5 is in the top left. Everybody with me on that? Okay, let's list some other ones. Let's go to angle 2. Which one would be corresponding to angle 2? Angle 6, good. What about angle 3? Which one is corresponding to angle 3? Angle 7, right? And why? Let's go back to 2. Why is 2 and 6? Why do they correspond? Because 2 is in the what? Top right. And what's in the top right down here? 6. Okay, 3 is in the bottom left. And what's in the bottom left over here? 7. That's why they correspond to each other. Do you see how they relate to each other? That's the relationship between them. All right, and one more. What's the other one? 4 and 8. Good. Okay. Did I say that they're equal to each other? No. They're not necessarily equal to each other. All right, which means eventually they might be equal to each other, but we're going to get to that in a minute. So those are all the corresponding angles. So you need to know that word. I will have a quiz and a test eventually, and I think the first question on the quiz and test, I'm going to ask you, I forget exactly the word, but it says something like, what is the relationship between the corresponding angles? And you would say that they are what? I'm sorry, I lied. That's for later on today, all right? I got ahead of myself because we kind of talked about that in the other class, and that's what I was thinking of. All right, so we know what the corresponding angles are. Everybody got that? All right, so 1 and 5, 2 and 6, 3 and 7, 4 and 8. All right, let's do another one. Let's do, I want you to look at 3 and 6. Now, I would not expect you to come up with this, but I'm going to give you the word, and I'm going to show you how it applies. All right, and we call these alternate interior angles. Just going to put the angle symbol for angles, okay? Look at 3 and 6. First of all, let's look at the word interior. The interior of what? Look at 3 and 6. Interior, those two white lines. It's in between. Everybody see that? It's in between those two white lines right there. 3. What are some other interior angles? Yeah, 4 and 5 are also interior. See, 3, 4, 5, and 6, they're between those parallel lines. Or, I shouldn't say that. I'm getting ahead of myself again. Between those two lines, see the two white lines? 3, 4, 5, and 6 are between, right? This is in the interior. Whoops, I went outside it. This is the interior of those two lines, yes? What is it out here? That's the exterior of those two lines, okay? 3, 4, 5, and 6 are interior. Now look at the word alternate. Alternate means they're completely opposite. They're interior angles, so 3 and 6 are in completely opposite places. You see it? Right? This is on the left side of the red line. 6 is on the right side. This one's up above. This one's down below. All right? 3 and 4 are not completely opposite because 3 and 4 are both above, right? And 5 and 6. But 3 is above and to the left. This is below and to the right. We call them alternate interior angles. So let's list the alternate interior angles. Angle 3 and angle 6. What do you think my other ones are? 4 and 5. Any geometry student will automatically look at this situation and say, oh yeah, they are alternate interior angles. It's a very, very, very popular thing in geometry, okay? Every geometry student would remember alternate interior angles. Everybody got that? Have I said anything about them being equal to each other or anything else? Nope. We're going to talk about that in a few minutes, okay? But not right now. Here's another name. Remember I said all the stuff in here was interior, then all the stuff on the outside was what? Exterior. Okay, so let's do that. We also have alternate. What do you think? I'll just shorten alternate. Is that all right? Alternate Oh, come on. Exterior angles. All right? Alternate exterior angles. First of all, let's list all the exterior angles. The ones that are on the outside of those two white lines. What would they be, the exterior angles? 1, 2, 7, and 8. Very good. Everybody see that? All right? 1's on the outside of this white line. 2's on the outside. 7 and 8 are both on the outside. Okay? What about the ones that are alternate? Completely opposite. 1 and 8. Very good. Okay, so angle 1 and angle 8. And give me some other ones. Why is the phone on? At least it's saying what I'm saying, talking about angles and stuff. So was that Siri talking? So look, what about 2 and what else? What's another exterior? 2 and 7. Very good. So angle 2 and angle 7. Those are all alternate exterior angles. Does that make sense? Look, 1 and 8. They're on the outside. 1 is in a completely opposite spot as 8. See how they're completely opposite each other? And what about 2 and 7? They're also completely opposite each other, right? And they're both exterior angles. All right, so those are my alternate exterior angles. You will have to know these. You got to know the words. All right, so make sure that you do. I've got another. Oops. Let's get rid of this circle right here. I got another set, and this is the last set. Then we're actually going to talk about parallel lines. Where can I put it? Right here. This is what the book calls them. I used to teach out of a different book years ago. And if I just put INT, what do you think that means? Interior, good. All right, so this one, I don't really like the word that they used. In my other book that I used to teach out of for like 17 years, I taught out of the other book, and we used to call them this. All depends on who you talk to, I guess. We used to call them same side interior angles. I kind of like that one better because I think it explains it a little bit more, all right? So let's use that, same side interior angles. Now, this is what the book's going to say, all right? So we will refer to consecutive interior angles, but I just want you to look at this word and see which ones are interior and which ones are on the same side. The same side of what? The same side of the red one, but what do we call that red one? A transversal, very good, okay? So which ones are on the same side of the transversal and are interior? 3 and 5, very good. Everybody see that? 3 and 5 are on the same side. They're both on the left side of the transversal, okay? And they are interior angles. Everybody got that? So angle 3, we'll put it down here. Angle 3 and angle 5. We got one more pair. What's the other pair? 4 and 6, good. So angle 4 and angle 6. So all we've done right there is just name the relationship, right? How they relate to each other. We name the relationship between those particular angles, all right? We already talked about this, but what's the relationship between angle 1 and angle 4? Well, they're equal to each other. What do we call those? Vertical angles. All right, we could keep going. 2 and 3, 5 and 8, 6 and 7. We talked about it already. All right, so you've got all these words, and you got to know what they mean and which angles match those words. Okay, so if I asked you list all the corresponding angles, I might put the numbers in a different, right? I might not go 1 through 8. I might go like, I don't know, 11 through 18 or something like that. You have to tell me which ones are corresponding, which ones are alternate interior, which ones are alternate exterior, and which ones are what? Consecutive interior. You think you can do that? Just have to know what those words mean, okay? And I think I explained what those words actually... Consecutive and same side interior, same thing. This is just a different way to name it. This is the way my other book used to name it. Nah, let's use consecutive. Okay, we're going to use consecutive interior. I just did that so you could look at them and say, oh yeah, they're on the same side. I kind of like that better than consecutive. Because consecutive, I don't know, it doesn't really tell you exactly where they're located, but I think same side does. Okay, yeah. All right, let's do something else. Now we're finally going to get to parallel lines, all right? We've done like a class and a half already, and we haven't talked about parallel lines, so let's do that now. And we're going to use the same stuff that we just finished doing. We're going to talk about that. Actually, you know what? I'm going to make that a little bit smaller so I have some room to write. So I'll just do this. All right, so there's my 2 lines. Now, I made them look a little different than the other 2. You remember how the other 2 are kind of slanted? What did I purposely do with these 2 lines? I made them parallel, exactly right. Okay. Now, you don't know they're parallel right now. Just looking at it, can you say for 100% that those 2 white lines are parallel to each other? No. Yeah, well, yeah, because there's an arrow. Did we talk about that yesterday with the arrow? No, I don't think we did. So I'm going to talk about it now. Now, technically, these have arrows on the ends, correct? Same thing with the red one. But if I wanted to show, if the book wanted to show, if I wanted to show on a quiz or a test that these were parallel to each other, this is what I would do. I would put an arrow inside of those 2 arrows right there. You see that? And usually they make it either a little bit thicker, a little bit bigger, all right, usually, all right? But it's always like inside there. It doesn't have to be dead in the middle, just somewhere. It could have been right here, just somewhere inside that line. So what do those 2 arrows mean? That means these 2 lines are what? Parallel to each other. What does it mean to be parallel? It means the lines will what? They'll never touch. They'll never intersect. Okay? Everybody see that? All right? Plus, it means they're coplanar as well. It means they lie in the same plane. But, yeah, we're basically just concerned that they don't touch each other. All right? So I've got 2 parallel lines cut by transversal. Do you hear me say that? Watch. If 2... Now, here's the symbol for parallel. I think I've shown you this before. If 2 parallel lines are cut, when I talk about this line going through the lines, a lot of times we use that word cut through, all right? So if 2 parallel lines are cut by a transversal, do we have that situation right here? Do I have 2 parallel lines cut by transversal? Yes or no? Did I spell that right? Transversal. Yeah. If that's true, then what I'm going to say next is going to be true as well. All right? And it's going to have a lot to do with what we just talked about, corresponding alternate interior and so forth. Okay? So this is the only time. Now, remember, were these lines parallel? No. All right? So I couldn't say that these were equal to each other, could I? But, and I'll tell you what, we'll try to stay in the same order. Watch this. Let's put some numbers in here as well. So if I go 1, 2, 3, 4, 5, 6, 7, 8. Now, you know which ones are corresponding. You know which ones are alternate interior. You know which ones are alternate exterior. And you know, take a deep breath, which ones are what? Consecutive interior. Okay? But now, if these are actually parallel lines, there's something more than just the names of them. All right? Here's what the first thing says. This is called a postulate. A postulate is just accepted without any proof. All right? It's really not that big of a deal for you, but that's what this is. Okay? So, here's the first one. Okay? That the corresponding angles, I'll just shorten it, corresponding angles are equal to each other. All right? So you know which ones are the corresponding angles, correct? Whoops, what did I just do? Here, let's try that again. There we go. All right, got a little ahead of myself. You know which ones are the corresponding angles, but if these 2 white lines were actually parallel to each other, what would be true about 1 and 5, 3 and 7, 2 and 6, and 4 and 8? They would be what to each other? They would be equal to each other, correct? All right, so let's come down here. So let's list them. Are equal, all right? So let's list them. Angle 1, I'm not just going to say 1 and 5 are corresponding. Now what can I say about angle 1 and 5? They are equal. That's right. So now I can say that they're equal to each other. The only time they're equal to each other is only when those 2 lines are what? Parallel, okay? If the lines are parallel, then I can say this stuff. If the lines are not parallel, I cannot say that 1 and 5 are equal. Everybody with me? Okay. So let's list all the corresponding angles. 1 equals 5. Angle 2 equals what? What's corresponding to angle 2? 6. So 2 and what? 6 are equal to each other. What about angle 3? What's equal to angle 3? Angle 7. And then one more, angle 4. What's equal to angle 4? Angle 8. And they're all equal to each other because they're corresponding angles. So 1 equals 5, correct? And I'll tell you what, I'm not going to do that right now. I was going to do something else, but that's good enough. All right, that's called a postulate. All right, the next ones are called theorems because you can prove them. We're not going to in here, but you can prove theorems. So what was the second one? Wasn't it alternate interior angles? What do you think might be true about the alternate interior angles? Look at 3 and look at 6. What does it look like they might be, the relationship between them? Look at 3 and 6. They're both obtuse, right? So what do you think? They're equal to each other as well. Exactly right. Okay, so the alternate interior angles are also equal to each other. So I'm going to put are equal. Now the book will say congruent. As far as we're concerned, this isn't exactly true. Some geometry teachers would get really mad at me if I said this, but basically congruent and equal are kind of the same thing. I'll say that much, all right? They're not exactly the same, but they use the word congruent. I will use the word equal and congruent. Doesn't really matter to me. All right, so let's list the alternate interior angles. So angle 3 would be equal to what? Alternate interior. Look at your notes. Which ones are alternate interior? 3 and 6. 3 and 6. Look, it can't be 7 because 7's not interior. It's exterior. Okay? It can't be 5 because they're not alternate. They're not completely opposite each other. You see it? What's completely opposite in the interior angles? What's completely opposite angle 3? It's 6. 3 and 6 are completely opposite. They are alternate interior angles. Okay? And the other ones is 4 and 5. That's right. So angle 4 must also equal angle 5. Alternate interior angles are something that we talk about a lot. Same thing with corresponding, but I don't know, for some reason it seems like students always remember alternate interior angles. What's the other one we had? Alternate what? Exterior angles. All right, let's list those. And what do you think's true about the alternate exterior angles? Let's take a look at them. So what's angle 1? What's an alternate exterior angle with angle 1? Angle 8. Look at it. This is acute. That's acute, right? So they kind of look like they're the same, don't they? And they absolutely are. All right? So the alternate exterior angles are also equal or congruent, however you want to say it, to each other. Let's list the alternate exterior angles. Angle 1 must equal what? Angle 8 and what else? 2 and 7, and they must equal each other as well. So far, watch this. So far, if I said, I'll tell you what, let's just keep that 1 there. Let's just do this in a different color. I don't know, I'm going to mess this thing up, but watch. What if 1 was, 50 degrees? Let's go through and find out all the angles, okay, 1 through 8. It's kind of like what we did with those vertical angles, all right, earlier. If angle 1 is 50 degrees, tell me something. Well, what's angle 4, by the way? It's 50. Why? Give me a reason. They're vertical angles. They're vertical angles, okay? What about 1 and 5? What's angle 5 equal to? Why? Well, they're equal, but that's not why they're equal. You can't say, no, 50, angle 1 and 5 are corresponding. Very good, right there. Because they're corresponding angles. 1 and 5 are equal because they're corresponding angles. Agree? Okay. What about 5 and 8? They're equal to each other for a couple reasons. They're vertical angles with 5 and 8, but they're also, look at 4 and 8. They're what? Yeah, but they're equal. I got it. I got a 50 and a 50. But why are they? They're corresponding. Very good. Okay, they're corresponding with each other. Everybody see that? So look, 1, 4, 5, and 8 are all equal. You got that? All right. Let's do some of the other ones. Let's do angle 2. What's angle 2 equal to? Yeah, but what number? How many degrees? What's the measure of angle 2? What is it? Where'd you get 130? Exactly right. Okay, look at this. That forms a straight line, doesn't it? 1 and 2. So they must add up to what? 180. So if you take 50 away from it, so 180 minus 50, what's that? That's 130. So angle 2 is what? 130. Let's go a little faster. Angle 2 and 3 are equal because they're vertical angles. So what's angle 3 equal? 130. Okay. Look at 3 and 6. Why are 3 and 6 equal to each other? Alternate interior angles. 3 and 6 are not corresponding. They're alternate interior angles. So angle 6 must be what? 130 degrees. 6 and 7 are equal. Why are 6 and 7 equal? Because of, well, not 6 and 7. 6 and 7 are vertical angles. Okay, so 6 and 7 are equal because of vertical angles. So check this out. All I knew was one angle. I knew that angle 1 was 50 degrees, and that was it. And then I could find all 7 other angles. Okay? That's pretty nice, isn't it? Let's see if some of that stuff is true. Alternate interior. Well, 50 and 50, they're alternate interior. They're equal. 3 and 6, they're alternate interior. They're equal. 1 and 8, they're alternate exterior. They're equal. Look at 2 and 7, alternate exterior. They're equal. You got it? 3 and 7, corresponding, equal. 4 and 8, corresponding, equal. You get the idea. All right? I think we covered them all. Except for, what's the third one? Or the fourth one, sorry, in your notes from earlier. We did this one, this one, this one. What was the fourth one? Consecutive. Very good. Let's write that down. Now, I want you to think about this. Up to this point, all this stuff has been equal to each other, correct? But what about consecutive interior angles? I forgot to put the interior. Consecutive interior angles. So which ones are consecutive interior angles? 4 and 6. Are they equal to each other? Okay, 4 and 6? Look at it. 4 and 6, they're consecutive interior angles. Are they equal to each other? What do they do? Well, there's a relationship. There's something special about 4 and 6. They add up to be 180. You see that? See, if this is 50 and this is 130, then what's true about 4 and 6? They add up to 180. We have a certain name. We have a word for this. I don't think I've used this word before, but I'm going to give it to you for the first time. It's a word that you're going to hear quite a bit throughout the rest of the year. We say the word is supplementary. Supplement, and then an A-R-Y at the end. Supplementary. What does supplementary mean then? What do you think? That's right. They add up to be 180. Supplementary means that they add up to be 180. So I cannot say that angle 4 is equal to angle 6. What can I say about 4 and 6? They add up to be what? 180. Give me another pair of consecutive interior angles. 3 and 5. That's right. 3 and 5. All right. So what can I write down? What little formula can I write down with 3 and 5? Angle 3 plus what? Angle 5. What does that equal? 180. Everybody got it? Should put degrees right here. So that's the only ones that are different. All right. Here's something that's kind of interesting. All the acute angles, look, which ones are acute? 1, 4, 5, and 8. All the acute angles are equal to each other, aren't they? Everybody see that? Look at the obtuse angles. What's true about all the obtuse angles? They're all equal to each other. So just looking at it, when you have this situation, and what's this situation? 2 parallel lines cut by transversal, okay, then all the obtuse angles are going to equal each other, and all the acute angles are going to equal each other. Okay? Don't ever say that 3 and 5 are going to equal. Why not? Because 3 is what kind of an angle? It's obtuse. What kind of an angle is 5? It's acute. So is there any way an obtuse can equal an acute? No, just by definition, that's impossible. All right? So don't ever say that 3 and 5 are equal. You got it? And there's a bunch of there's several other things that aren't even named here that could be equal to each other. Like look at, what was I going to do? Forget that. Let's just keep going. I got one more thing to do. All right, let me do this real quick. When's this over? Quarter of? Yep. Oh, goodness. I got 10 minutes. Okay, I think I can do this. I'll do this kind of quick. So watch. I've got 2 parallel lines. Cut by transversal. But watch this transversal now. This is not just, hey, I'm talking. This is not just any old transversal. Okay, I drew this specific. How do you think I drew that pink one to the yellow ones? Yeah, so what kind of angle do you think it makes? A right angle. Terrell, did you bring my desk back? You had a desk. I didn't have it. All right, so actually they put it down here. It doesn't make any difference. Okay, now watch this. If this is 90 degrees, then what do you think this angle right here is? Okay, and why? You actually have a reason to back it up. Because look at these 2 angles right here. This angle here, we'll call it angle 1, and this angle here, we'll call it angle 2. What's the relationship? Are they corresponding? Are they alternate interior, alternate exterior, consecutive interior? What are they? They're consecutive interior. What's true about consecutive interior angles? They both add up to 180. So if this was given as 90, what does this one have to be? It's got to be 90 because 90 plus 90 is 180. Everybody see that? All right, that's not too hard to see. That's a theorem. That's like all by itself. And now we've got less than 10 minutes, but we can do this. Let's do one big old example. So watch this.
What was that word that instead of supplementary, it's
consecutive interior angles? I don't know. Supplementary. As supplementary. Okay. All right, let's do this. Let's make a transversal. I'm going to slant this transversal though. But then I'm going to make another transversal and it's going to be perpendicular. I don't think I used that word yet today. Did I? Perpendicular? When it makes a 90-degree angle, what does that mean? It means those lines are, look, that pink line and that yellow line right here are what? It does make 90 degrees, but what do we call it? I just said it a second ago. Yeah, it's a right angle, but I just said it. Say it. Perpendicular. Perpendicular, okay? So these lines are perpendicular. All right, so this yellow one is also perpendicular. All right, let me put some angles in here. Let's see. This is 2, 3. That's 4. This is 1. That's 6. And this is 5. All right, now, one thing I almost forgot. See those 2 white lines right there? Can you make an assumption that they are... Shh. Let's listen. Come on. You guys have been really good today. Yeah, it's up there, right there. All right, so these are parallel to each other, all right? So they give them to you like that. So now what we want to do, we want to find what each of these numbered angles is equal to. That's the question. So there's actually 6 answers to this, 6 things we have to do, all right? And we have to find what it is. But they give you some information. They kind of tell you angle 1. And you've seen stuff like this before. 7y minus 15. And then there you go. And they also tell you angle 2, which is 10 times y plus 11. Little degree symbol. Okay? That's all they tell you. And you have to find what the angle measure is for angles 1, 2, 3, 4, 5, and 6. All right? So what we need to do is find a relationship between angle 1 and angle 2. Okay? Are they equal to each other? Are they supplementary? is something else. Do they add up to be something else? I don't know. Let's take a look. 1 and 2. So look at angle 1. Look at angle 2. First of all, are they equal to each other? Is angle 1 and 2 equal to each other? No, because 1's acute and 2 is what? Obtuse. So there's no way they're going to equal each other. So what do you think might be true, though? They add up to be 180. All right, I'll show you why. Watch. Look at 1 and 3. There's a word, several words, that is a relationship between 1 and 3. What are they? They're on the same side of the transversal. They're interior angles. So my old book said what? Same side interior, but what do we say in this book? Consecutive interior angles. So what's true about 1 and 3? So angle 1 plus angle 3 are supplementary. So they add up to 180, correct? Now, what about 2 and 3? What's true about 2 and 3? They're vertical angles. So what must be true about them? They're equal to each other. So watch. Instead of writing angle 3, what could I write? Angle 1 plus, what do we say? Angle 3 and 2 are equal, right? So if 3 and 2 are the same angle, or equal to each other, not the same angle, but they're equal to each other, what can we say? Angle 1 plus angle 2 is equal to 180. Okay? Do we know angle 1? Kind of. What is it? 7y minus 15. Do we know angle 2? Yeah, kind of. What is it? It's 10 times y plus 11. So what are we going to do? We're going to add them up, and we're going to do what to them? Set them equal to 180. So here we go. Angle 1 is what? 7y minus 15. And then we're going to add it to angle 2. What's angle 2? 10 parentheses y plus 11. What do they add up to be? 180. Terrell, you're the last one to not pay attention because you came in late. I know it wasn't your fault, but you still need to pay attention. And it doesn't matter. Right now, this minute, okay, you need to pay attention. So let's do this. Let's solve for y. Let's do it quickly because I'm kind of running out of time. What can we do first? I would distribute that 10, wouldn't you? So let's just write 7y. For some of you guys, this is a problem, doing this algebra. It's why it took 3 weeks at the beginning of the year to do algebra so that we could get to this point right here. So let's learn it now if you didn't learn it before. Distribute the 10. What does that give us? 10y plus 10 times 11, well, that's 110. All right, let's add like terms. 7 and 10 is 17. Add those up. Negative 15 plus 110 is 95. I'll do the math for you. That's equal to 180. Subtract 95 from both sides. All right, so 17y equals, that's 85. Divide by 17. And 85 divided by 17 is 5. Oh, come on. Y equals 5. Is that my answer? No, far from it. All right, but it's very important. That's the key. All right, y equals 5. So what do I want to do? Let's find angle 1. So what are we going to do to find angle 1? Plug it in. That's right. So let's plug it in. So it's 7 times 5 minus 15. 7 times 5 is 35 minus 15 is 20. So what's angle 1? It's 20 degrees. Okay? Really, that's all we need. We can find everything else. All right? Look at 1 and 4. Let's do that first. Let's do 4 first. So angle 1 is 20. Look at angle 4. What's the relationship between 1 and 4? They're equal to each other, aren't they? All right? Because they're corresponding angles. So angle 4 is going to also be what? 20 degrees. Yes. Yeah, angle 2. Is that what you said? Yeah, angle 2 would be 160. Why? Because look, you form a straight line right there, don't you? Okay, and then 180 minus 20 is 160. Well, 2 and 3 are equal because they're vertical angles. It's like dominoes, isn't it? You push one and they all start falling over. Okay, that's kind of what's going on here. So this is 160, so what's angle 3 going to be? It's going to be 160. Now, that's all of that. Look at 5 and 6. What did we know about that one right there. It's a right angle. So what is the angle up here going to be? It's going to be a right angle, isn't it? Okay, so what we talked about earlier. So what's angle 5? 90 degrees, easy, right? Without doing any math. Knowing that that's perpendicular, if those lines are parallel, that has to be perpendicular, okay? What about 6, though? And this is also right angle, isn't it? So if this is 20, how do I find 6? Yeah, 90 minus 20. And that gives you 70. So angle 6 is 70 degrees. So your homework is on the lesson plan. I'll write it up here. Yeah, I'm writing it right now. That's what I'm doing. It's page 111, and I think it's 8 to 21. All right, so that is your homework right there. Let's do on Monday, okay? Monday. Have it done for Monday.